Sure, that's fine. Yeah, go ahead.
Can you enable screen sharing for me?
Okay, Sarah, can you enable screen share? Hey, Sarah. And Sarah's saying, yeah, I'll do that right now.
Thanks.
Hi, everyone. We are going to wait for just another minute before we get started with our presentation.
I still can't share my screen. Oh, I think now I should be able to do that. Okay.
Hey, hello again. We're going to go ahead and get started now. Hello, everyone. Thank you so much for joining us today. I see that we have a nice size audience here already. Thank you again for logging in and showing up. It is my pleasure to introduce to all of you Dr. Malihe Alikhani from the University of Pittsburgh, where she works in the Department of Computer Science. Dr. Alikhani got her PhD from Rutgers University, excuse the interpretation, from Rutgers University in computer science. Her recent research has focused on natural language processing, and she has an interest in multimodal communication. I am absolutely delighted to welcome her to present to all of us today. This talk has been organized by the CREST Network, Cultivating Research and Equity in Sign-Related Technologies. We will continue to have a series of lectures throughout the spring semester and summer. This talk kicks off our first talk of this calendar year. Dr. Alikhani's talk today is entitled Including Signed Languages in Natural Language Processing. Please join me in extending a warm welcome and watching what is sure to be an enjoyable presentation. Oh, we'll also have Q&A. Please use the Q&A feature in Zoom if you have any questions. Type in your questions and again in the Q&A box, and we'll be monitoring those. You can also feel free to use the chat for general commentary or informal conversation with other audience members. Thank you. And again, thanks so much for being with us today, for those of us in the audience, and thank you, Dr. Alikhani, as well. Thanks again. Looking forward to your talk.
Hi, everybody. Good morning. I'm very excited to be here to share some of my recent research results with you. Thank you, Lorna, for the nice introduction. and thanks for the invitation. Okay. To begin with, sign languages are fully fledged languages expressed through handshakes and movements, as well as other cues such as facial expressions and body positions. They are independent spoken languages, and they are capable.
Sorry for the interruption. One
Sure.
moment. We need to have the interpreter pinned. Sarah, the audience members are not able to see the interpreter. Sarah, can you pin both Jen and Dr. Alikhani? Thank you.
Let me know when I can start. Okay. Is it good now?
On the thing, I'm just checking in. Looking at the comments, or excuse me, the comments in the chat box.
Okay, let's proceed and
Sure. Do you want me to try one more time?
it seems that there's still an issue with the spotlighting, so one moment.
Okay, sure.
Okay, we are getting better reports. Thank you for your patience, everyone, and we will continue now.
Okay, cool. So there are around 200 documented sign languages and an estimate of 70 million deaf people around the world. They are also the primary and preferred means of communication for deaf communities among themselves and when interacting with non-signing communities. While advances in natural language processing gave rise to useful language technologies such as automated translation, virtual assistant. In languages such as English, all of these natural language processing systems expect text or speech as the input. This automatically excludes all signers from modern language technologies. This limits the possibilities of technology and risks further suppressing signing in favor of spoken languages. We believe that it is important to make language technologies accessible to signers as well, so that everyone can benefit from technology by using their preferred language. The talk today, in this talk today, I'm going to explain three papers, three of my recent papers. The first section is a paper that won the Best Theme Paper Award at the ACL 2021 conference, where we argued why we need to include signed languages in natural language processing. In the second section, I will talk about a machine learning model for signed co-reference resolution. And in the third section, I will talk about modeling prosody and intensification in sign language generation. And before moving forward, I should say that in all of these papers and research work, I have collaborated with faculty at Gallaudet and students. Okay, part one, sign language processing. Who is working on sign language processing? I will give you just a few seconds to look at the graph. So who is currently working on sign language processing? Well, to date, research in sign language processing has been mainly led by the computer vision community, with little involvement from the natural language processing community. This isn't unreasonable, given that a decade ago, we lacked the visual processing tools to handle sign language videos before further modeling them. However, current sign language processing often fails to address or leverage the complex linguistic structure of sign languages. So with the current advances in artificial intelligence and the technology that we have, we can better recognize sign, understand the boundaries of hand gestures. However, what do they really mean? And how can we use that to develop technology for the purpose of better communication in education, health, and other domains? That remains an open research question, an area that requires a lot of effort from natural language processing community, computational linguists. This in this paper, we argued how the computer vision community needs to collaborate with natural language processing in order to build tools that can make this facilitate communication. So our paper starts by giving an introduction to sign language linguistics, including phonology, simultaneity, how references are established and grounded in sign languages, and finger spelling in sign languages. Next, we cover the different existing ways to represent sign language, including videos. So in this slide, you can see snapshots of a video. We turn that to abstract poses. And then we learn various notion systems to represent them. But representing these poses in meaningful ways for computers is still an open problem. Our paper also presents existing sign language resources, such as bilingual dictionaries, finger spelling corpora, isolated signs, and continuous sign corpora in form of videos. So for a survey of existing sign language datasets that are particularly useful for research in computational linguistics, you can check our papers. Then we survey the current tasks in sign language processing, such as sign language detection, when someone is signing in a video, identifying the language that is being signed, whether it's ALS or BSL, segmenting sign language videos into meaningful units, recognizing sign glosses, and translating signs into spoken languages, as well as producing a signing avatar from a spoken language input. The current approaches often do not rely much on theories of sign language linguistics or natural language processing methods that may help to address these tasks more efficiently. So these systems are usable and deployable. You can find more details, again, in the paper. I'll refer you to the paper for those. Okay, so in order to address these issues in this paper, we argue that there is a bottleneck in sign language representation. The vast majority of NLP models expect a discrete representation of input text and image. Excuse me, speech. We therefore need a way to represent sign language data with good efficiency and minimal information loss. Current approaches often use glossing as an intermediate representation. However, linear systems of glosses cannot fully capture the simultaneity and spatial organization of sign language, resulting in an inevitable information loss. Gloss annotations are also language specific and lack a standard between different data sets, which limits data sharing and grouping and adds overhead during modeling. We therefore urge the development of an efficient, universal, and standardized method to represent sign languages. We believe that developing known natural language processing models and pipelines for sign languages will help us better understand how to model them, moreover, even though signed and spoken languages are expressed in different modalities, they both express the grammar of natural language and fundamental theories of natural language processing can be extended to sign languages. We therefore encourage developing core natural language processing tools for sign languages, such as syntactic analysis, part of a speech tagging, name entity recognition, co-reference resolution, which are all valuable tools that then will allow us to build higher level systems that are usable. We also encourage the natural language processing community to collaborate and exchange ideas between multimodal NLP and sign language processing researchers. On the one hand, we believe that the theories and methods to process multimodal messages can enhance the joint modeling of vision and language. Which is critical for sign language processing. On the other hand, meaning in spoken languages is not only conveyed through speech or text, but also through visual modalities. So studying sign language, we believe, will enable us to also better understand and model face-to-face spoken languages. To train deployable models, we need large enough data sets that accurately represent real-world data. However, sign languages have very little labeled and unlabeled data, placing all of them in the class of languages with lowest resources. And this is, of course, for computational research. Moreover, to mitigate the challenges of scarce resources, popular sign language data sets used for research are often restricted to small domains, such as weather forecasts, and have a small, very small vocabulary size. And because the lack of sign language data in the world Collected data are often filmed in studio conditions or taken from interpreters of spoken utterances. And it's also hard to find a diverse signer demographic or native signers. Therefore, with the current resources, it's challenging to develop models on data that can fully capture the complexity and the diversity of sign languages. At the same time, obtaining sign language data is especially difficult as data collection requires significant effort in recruiting, recording, annotation. Finding qualified annotators is always challenging. Collecting and annotating together is time-consuming. It's been reported that in order to label 1 minute of sign language data, we may end up spending up to 600 minutes of collection and annotation. And so in the paper, we urge researchers to develop tools to automate this process, facilitate data collection, also annotation part. We also give details about what really matters and how we can build these tools in order to achieve our goal. We also argue for developing tools that are user-friendly. There has been reports that some of these tools are not comfortable for students or our subjects who are producing data. This involves these gloves that you have, I'm sure you're familiar with, that are not the most comfortable gloves, or attaching wires to users and subjects. In particular, or in some, we advise the natural language processing community in this work to build connections with deaf communities in order to hear about their needs and to develop technology that they like to use and that is important and useful for them. And the final message of the paper is, let's include sign languages in natural language processing so we can develop tools that everybody can use. Okay, I have only about 10 more minutes, or maybe I can take up to 15. So now I will just give you a summary of 2 projects that I'm very excited about. One is using natural language processing and computer vision tools to better understand and process sign language, in particular videos. In this project, we develop a model that takes as input sign language videos and resolve references and co-reference. So just a couple of slides of summary. Co-reference resolution in natural language processing is the task of identifying all references to the same entity in a discourse. So in this example, we have I and me that refers to one entity, Alice and she to another, Bob and he to a third entity. coreference resolution is a critical component of any natural language understanding model. And higher level NLP applications, including summarization, translation, information extraction, search. Yet it is completely unexplored in natural language processing. So in this paper, for the first time, we present the task of sign coreference resolution. And I know that you're seeing a familiar face here. This is Kenny Dahan, who helped us in this paper. What we do, we introduce a task, we annotate a data set. And I should say that the data set is the German Sign Language and not American Sign Language, only because we don't have access to a face-to-face dialogue in sign language that is an American Sign Language. So we developed a data set, annotated coreferences, mentions in a German Sign Language. We developed a machine learning model that can then automatically resolve references. And I can show you some results. As you can see here, for some classes of pronouns and coreference, we achieve the F1 score of 92%. Some of them are more difficult. So we are getting lower scores. On average, the F1 score is around 60% in different classes. And this shows how challenging this problem is. And we invite other researchers who are interested in sign coreference resolution to use the data annotation tools, the annotation tools that we have built for this, and build up on our unsupervised model to solve this task. I will share the code and data after this talk with you. I'll share the link. I see a hand. Should I go ahead and take that question? Or should I wait until the end?
Lorna just added in the chat to wait until the end.
Okay, sure. Another project that I wanted to just share with you, at least a summary of it, is modeling intensification in sign language generation. This project is in collaboration with Lorna Kwan. Prosody represented in the visual modality with iconicity, gesture, space utilization, and temporal pauses in sign languages. And now I will give just a few seconds so you can review the slide. As you can see, there are modifiers such as very, less, and other types of other kinds of words and prosodic phenomenon that are completely in sign language are visualized in this signing space. The speed of the sign matters. Repetition matters. Sometimes there is up or down some special signs that would signal the size or how you would like that adjective or adverb to be modified. When we looked at the existing corpora of sign language, and that this was for the weather forecast, we observed that the subtleties and modifiers are not represented in the gloss system, and thus a lot of it was lost. So in sum, what we did, we characterized ways that these subtleties are visually communicated. And we came up with a model that can augment the gloss system so we can represent meaning. And then we use that for generating skeletons automatically. Sorry that in the interest of time, I'm skipping a slide, and I'm not going to get into the details of the model, but you will see that the model will receive the text. It will turn that text into gloss, and it will generate these very naive skeletons that you can see on the screen. You can see that we have made some progress in automatically generating these skeletons, but see how naive they are, how difficult they are to interpret really. We have a long way to get to a point where we can automatically go from text to usable skeleton. In our model, we also show that when we augment glosses, in our paper, we show that when we augment glosses, the skeleton make better use of a space. They better represent meaning and translate. In particular, we observed an increase in the number of adjectives and adverbs that our skeletons are now able to generate if you compare it with the baseline. Okay, so now I'm going to just mention a couple of work in progress, and then we can start the QA session. One of the current ongoing projects in my lab is trying to learn coordinated facial and hand gestures in order to generate better generate sign language. So here, for the first time, we're using facial gestures, facial expressions using the open face tool. And we are adding faces, as you can see on these slides, to the skeletons. We observed that it is very important to model and understand face and facial expressions and put that together in a timely manner with hand gestures. Here are a couple of examples that show how facial expressions can actually change the meaning. I'll give you a second to look at this slide. Here is another example. Again, you can see how facial expression play a role. In our study, we found that up to 40% of the information in the corpus was lost when we excluded facial expressions. This shows how important it is for us to model face in coordination with hand gestures. So our idea was to include facial action units and then design a machine learning that is more efficient at that learned to model sign language, to model facial expressions automatically and use that model for generation. This project, again, is in collaboration with Gallaudet colleagues and students. They have kindly helped us, especially in this slide, you can see with the evaluation of the results of our system. So how they like it, whether it's meaningful or not, how we can improve it. I'll give you just a second to look at the slide so you can see an example of what our system produces. Another work in progress, which is very early on, we are working on establishing collaborations with sign linguists in Yucatan and Iran, in Mexico, Latin America, parts of Latin America and Iran, to document sign languages in these regions. Okay, so a summary and a conclusion of the talk. We have put together 3 data sets that are publicly available. It can be used for sign language modeling, whether it's computational or not. We have contributed 2 models, one unsupervised model for sign coreference resolution, and one, again, machine learning model for sign generation that can translate text to sign and sign to text. There are some key challenges for us to build computational models for sign languages, as well as designing useful tools. And on top of that, LIST is having very limited data sets. It's the difficulty of the evaluation process. It is developing machine learning models that not always generate the outputs that are publishable and usable. So answering questions such as how we can effectively combine cognitive science, specifically linguistics of sign language, with machine learning tools in order to build usable models is still there. And adherence to the code of ethics for such technology. One example of that is, how do you blur eyes, or how do you make sure that the user is happy providing data for privacy purposes? Then this is just one example. I believe that as the technological advances will grow, especially these days, we need a code of ethics in place, set of principles for students and faculty who start doing research in sign language processing. So they're aware of their potential, but also potential harms that their technology can cause. We would like to avoid any potential harm. The reason why I work on these problems and the vision behind it is that I work towards developing linguistically aware and cognitively aware usable sign language processing tools to enable learners with diverse capabilities succeed in communication and provide equal access to language technology. With that, I would like to thank my wonderful students who have done a lot of valuable work to put these papers together and finish these projects successfully. A special thanks to my Gallaudet collaborators, Dr. Lorna Kwan, Dr. Kenny Dahan, Dr. Julie Hashkasang. They have helped us develop these systems, provided insights, helped us a lot with data collection and evaluation. I like to thank the CREST network and the Pitt Funding Office of Sponsored Program who has funded these projects in the last year, pretty much. And thank you for listening to me and for the invitation. I will share the slides with you if you'd like to check the details. Here are the list of papers. Please reach out to me if you need the code to our software or data or any other support that we can provide. Our goal is to further this research for good use. Thanks. Now I can take questions.
Hi, everyone. Oh, there you are, Melissa. Hi. Am I visible? Do I need to be spotlit? Great. Thank you so much for such a fascinating talk, Dr. Alikhani. I feel like the 50 minutes was insufficient to talk about all of that information. So I'm already feeling the need for a part 2 and to have you back. I noticed that you said that you use open face at one point during your projects to process facial expression. And I think that that was such an important point to make because there are 3 questions in the Q&A that all have to do with facial expression. So this seems to have really piqued a lot of people's interest. So we'll get to those questions. And for anyone that would like to clarify or add a little bit to their question, you should be able to turn your cameras on. You can also chat in comment, make your comment in chat or ask in the chat to have your video enabled. Okay, with that, I will start with the first question that was asked by Yumi Lee. Can everyone see the Q&A or should I sign it? I'm not sure. I think to be on the safe side, I'll just sign it. What was that, Lorna? Yeah. So Yumi asked, would there be any studies on the difference between non-affective linguistic facial expressions from affective facial expressions? There is research that elaborates how they are processed differently by hearing viewers and deaf viewers. And as a related question, I'm going to skip down to number 3, which is Athena, which was asked by Athena Willis. She asked, building on Yumi's question, regarding linguistic versus affective representation of facial expressions. What about gestures or spontaneously created novel signs? And I'm going to turn my camera off while you give your response so that you'll be bigger on screen, and then I'll come back on to state the next question.
Sure. So these questions are wonderful. In our study, because we could only, unfortunately, focus on weather forecasts, we couldn't really study affective facial expressions. We did found examples, though, in other smaller data sets, and I'd be happy to share that repository with you. But the short answer is yes. Unfortunately, because of the limitations of the data set, we haven't studied affective or spontaneous signs. However, I can, and I have your name, I will definitely reach out to you, email you if it's possible. There are tools in linguistics and computational linguistics of just the spoken languages that would allow you to study which sign, which gesture is coordinated with speech, which one is independently contributing. So I assume that building on those tools, even with a small data set in sign language, we will be able to leverage those and potentially study innovation, whether it's lexical or not, as well as the different role, whether it's affective, it's an adjective or not, adverb. Is it just a noun or action that people are gesturing? I'll give you an example. In spoken languages, we say, chop the tomatoes, and we might as well do something like that. So that's an action being visualized and gestured or represented in the face. Sometimes gestures or faces, facial expressions are standalone. You ask me a question and I will say, without any speech. And that's on its own communicating a meaning. So there are resources. These are wonderful questions. We didn't get to study them, unfortunately.
Great. I'm seeing responses in the chat. So people are thanking you for those comments and that response. I'll let you take a moment to catch up on those. I see another question on a similar topic, so I'll skip to that one. It was asked by Jason Lamberton. Jason asks, how do you incorporate facial expressions and eye gaze in your translation models? And once we get Jason's question answered, I'll go back up to Dan Green's question, trying to cover as many topics and answers as we can. But let's start with Jason's question about eye gaze and facial expression.
So Jason, thank you for your question. We are not taking into account eye gaze as of now, but for facial expression, we run models that can give us extract features from face. These models will give us the boundaries of lips, of chin movements, to some extent, shape of eyes, the position of the face. And we incorporate that with the representation that we have from the hand gestures. The way that we do that for machine learning in machine learning modeling is an easy way to do it as a baseline model is to just, once you get a mathematical representation of them, just add them up. Some of these machine learning models have the capability to learn on their own how to combine these features, how to use them. When we look at how our model is doing it, to the extent to which that we can, because that's not always possible, we see some alignments, some standalone features where face is really contributing and not hand gestures that much. If you like to see examples of that, I'd be happy to share some results with you.
I'm going to guess that Jason would like to know more, and he's going to want to see some of those results. Speaking for myself, I'm also interested in seeing that. So thanks for the offer. Okay, now let's go back up to Dan Green's question. Dan asks, what is the best way to quote unquote sell or push for this kind of research to non-signing computer scientists that may not readily understand the importance of it?
Ben, this is a good question, and what has really worked for me is emphasizing on how communication is multimodal. When hearing people talk, the hand gestures help a lot, the facial expressions help a lot, the way that we orient ourselves helps a lot in facilitating the communication. And when we study sign language and we develop tools for sign language processing, it's been shown that that is very, very insightful for designing better models for spoken languages. I will give you an example. I talked about sign co-reference resolution. The way that in sign language you say Alice, Bob, so you use a space to communicate. This is flexible. You may sign Alice once here, just 1 inch further. It's ambiguous, but signers can pick it up without any problems. We can use that model to resolve ambiguities in pointing gestures. When we point to objects that are very close, there is ambiguity. When we point to events while speaking, we say the event, the musical event in New York, it's a spatial, when people speak, they use all of these gestures, and sign language is really, really helpful, and the grammar of it, it just, helping us resolve these multimodal ambiguities in face-to-face conversation. So that's just one example. Another one is iconicity. Language is iconic. And the role of that in sign language linguistics, also when we develop tools for sign language processing, the extent to which we'll learn about that, ways that we interpret them, understand them cognitively, that is really, really helpful for designing models for spoken languages. Of course, these are just examples, and I can go on, but I hope that this answered your question.
Thanks so much for those examples. So I see that we are just out of time. We are a tiny bit past 10 o'clock. So we will need to wrap up for the morning. I see that there are a number of great questions still left. This has been recorded. So maybe what we can do is take some of this conversation online and we can talk about how to respond. Maybe we can put a response or the questions and the response online. For those of us, for those of you who have joined us this morning, thank you so much for logging into today's presentation. And Malihe, you mentioned that you've got some publications that you could share. So we could send those links to everyone that registered for the Zoom talk this morning. I think that most of you who've attended today are already a part of the CREST network or our listserv. So we can make the recording and links available there for anyone that would like to re-reference the talk or share it with anyone. So again, thank you so much, Dr. Alikhani, for joining us today. Thank you so much to the audience members. Thank you to Jen and Charette for interpreting, and thank you to the captioner. Thank you to Sarah, who did all of the intense behind the scenes work to make everything work out.
Yeah, thank you very much for organizing this. This was a lot of fun. Please feel free to email me if you have questions. I will also share some resources with you. Stay in touch, and I hope to see you again.
Likewise,
Bye.
thank you so much. Happy Friday. Bye.
Happy Friday. Bye.